It's fine, guys. So this is your chapter 5 EMF equation of what? Of alternator of alternators, no? Alright, okay. So basically you must know these formulas that I write on the board. And as I always specify, like most of the formulas that are not given on your formula sheet. Like for Electro N5, mostly the formula sheet is not useful. So you must know the following, and then the first formula that you have is to calculate what? The EMF in what? In phase. Ne? They said the formula to calculate your E phase is gonna be 2 KF KP KD. This is the flux multiplied by the what? By conductor per phase, then multiplied by the frequency. Or you can also use the second one, which says 2,222 KD KP Z phase multiplied by the flux multiplied by the frequency. Ne? Alright, okay. And let's say you are not given the frequency, you can also use to calculate the frequency using which formula? This one, whereby you are given what? The speed. And remember, speed is given in ref per mean. Speed is given what? In ref per mean. And then you also multiply the pole pace. And as I always specify, you are going to be given number of what? Number of poles. So you must divide them by 2 to make them pole pace. Because when you are calculating your frequency, you always divide by by 2 on your pole pace. And then you divide by 60. And I said you only use this 60, you only divide by 60. Let's say you are given a speed in ref per mean. If they are going to give you a speed which is ref per second, which means there's no need for you to divide by 60. Just gonna be small letter n multiplied by pole pace. Alright, okay. So let's say you also wanted to calculate the number of what? Number of armature conductors, which is ZT. It's gonna be the number of phases and multiplied by Z phase, whereby I said your Z phase is what? It's conductor per phase, and you have different formulas to calculate the Z phase, You also have this one which says to calculate Z phase is gonna be Z per slot multiplied by the total slots. But mostly, guys, the reason why I write NB on these formulas, mostly use these formulas. This one, most of your question they only use this type of formulas, whereby you can calculate your Z phase using the number of slots per phase multiplied by the Z slots, and then how do you get your Z slots? You're going to use this formula. Alright, okay. And don't mind about this one of N, mostly it doesn't come. And you also have another formula to calculate your ZT. They're saying the conductors multiplied by the slots. This is the same thing that you're doing at N3, whereby you're given the number of conductors and slots. You still remember this one. This one is just as straightforward. And then you can also calculate your Z phase using the other formula. You say ZT divided by the number of what? Number of poles. And then you also have the other formula of calculating your conductor per phase. You only use this one when you are given what? The current, which is the I phase. If you don't have I phase, it means you can.
The number of poles we don't take in pole pairs.
No, on this one you use number of what? Number of poles. Is the same thing with this? Where is it? There's a formula that I want. There's no another formula which you have number of poles there. Let me see. This is the one. Okay. Here, this one. On 18. You see that this one it says now for you to get number of what? Number of slots before it's gonna be the slots multiplied by poles, not pole pace. So on this one and also that one, you're going to use poles, not pole pace. Alright, okay. And then you also have, if they want you to calculate what you call the number of turns per phase, it's gonna be Z phase divided by 2. And remember, I said whenever they give you an EMF, if they don't specify it's what? It's a line EMF. Same thing with the voltage. You said whenever they give you a voltage and they don't specify if it is a phase voltage or what, a line voltage, it is going to be what? Automatically to be what? A line voltage. And you know, on this one you have to use the phase value, so it means you have to divide by 3. Alright, okay. And then you also have to calculate the distribution factor using this formula, but mostly they don't ask you about this. Okay. So as I said, mostly on your if you check on your questions, these formulas, these two of them, this is what they use mostly, and also that first one. Let us do it's April 2019. You can just share that. April 2019, question 5.2. No, it's different. It's not that one. It's the one which is in your question. Okay, so let us see 5.2. They are saying a 3-phase star connected alternator is the frequency of 50 or 50 Hz. Let us just write given information. Okay, I'm given the frequency, which is 50 Hz. Okay, and they're saying they said a three-phase star. So it's a three-phase first, and it's also connected in what? In star. So the connection is also important. It's a three-phase, and it's also connected in star, and then you have a frequency of 50 Hz. And they're saying to give a line voltage of what? Of 12 kilovolt. And on this one they did specify it's a line voltage, which is E line, or 12 kilovolts. All right, okay. And they're saying when the machine is in an open circuit, no? All right, okay. They're saying the flux per pole is what? 0.18. I'm given the flux, which is 0.118 Webers. They're saying assume the full pitch coils are assume the full pitch coils and the starter is what? 6 slots per pole per phase. And then I said when they gave you this thing of 6 slots per pole per phase, just take as what? It's slots. Okay. So I'm given the slots, which is 6. Okay, and they're also saying the speed, which is N of 600, 600 RPM per min, and the distribution factor, which is 0.997. All right, okay. And there's also something that I didn't specify about your, what is it? About your KP, which is the pitch factor, and this one also. The same on KP, you take it as 1 only if its coils are pitched. So if your coils are pitched, you're going to take your KP when you're using this formula as what? Is 1, and then your KF, the same for a pure sine wave, you take it as 1.11. So you'll find that most of the time it won't be given. So if they say it's only for coils are pitched, then you're going to take your KP as 1, and this one, your KF is 1.11. All right, okay. So what is the question saying? Does it calculate the number of slots? Calculate the number of starter conductors per slot. They want us to calculate it per slot. Okay, how can we calculate our Z per slot? So mostly, guys, before you use any other formulas, as I said, mostly they use these two formulas that I've written in. So make sure you check if these two formulas are not going to give you what you want to calculate for. Alright, okay. So on 14, I have a formula that says Z phase is equals to what? Number of slots per phase multiplied by Z per slot. So I'm looking for what? For Z per slot. Alright, okay. And then do I have the number of what? Number of slots per phase? I don't have, but I can calculate my number of what? Number of slots per phase using this formula. So please on your notes, please also write it on this formula. Okay. So let us see. I can get my number of slots per phase, which is what? Which is slots multiplied by poles. Okay, let us check. Do I have the slots? I do have the slots at 6, but do I have the poles? I don't have the poles. You see that on the given information, you're not given any poles, but I can calculate the poles since I'm given the frequency. I can use also this formula to calculate my number of what? Number of poles. And I said in order for you to divide by 60, you have to check if your speed is given RP min. In that case, I'm given 600 RP min, which means I can calculate my slope, which is they're saying F is equal to N multiplied by P divided by 60. So it's gonna be F multiplied by 60 is equal to NP, and then I divide by N. I divide by N. This one cancels this one, and then my P is equal to what is my frequency? It was 50 Hz, multiplied by 60, divided by the speed of what? Of 600.
5.
Is that?
5.
It's 5, and also you see what I said your formula says poles, but when you are calculating, this is pole pairs, so you need poles, no, you need poles, not pole pairs, so it means I have to multiply by what? By 2, okay. I'll get my number of poles is what?
10.
Is 10. Alright, it's fine. So which means now I have my slots, I also have my poles. So which means I can calculate number of slots per phase. And my slots is what? 6 multiplied by 10. You're going to get what? 60. Just move this thing to this side a bit. Okay, it's fine. I'm getting 60, né? Alright, okay. So now here I can now use, do I have Z phase? So now I have the number of slots per phase, né? I'm looking for Z per slot, but do I have Z phase? No, I don't have Z phase, né? So how can we calculate Z phase here? You check with your given information, né? Let us check. How can we calculate our Z phase? I think we can use the first formula, né? Since you see that you are given E line. So I can change my E line to be E phase and then I'll use it. And I also see that I'm given also the flux and then the frequency. I can also use this formula. Né? So firstly you have to change your E line to be what? To be E phase. Né? Okay. So for me to get my E phase, it's gonna be what? E line divided by root 3. What is my E line? It's what? It's 12 times 10 to the power 3 divided by root 3. One?
6928.
6928.
20.
20? Just like this.
203.
203, no? Okay. And is the EMF, which is what? The voltage, no? Alright, okay. So let us say check here. Did they give me the distribution vector, which is KD? They give me, which means I can also use this one, eh? Okay, I have my KD and then I can take my KP as what is 1. I can just use this formula and make my Z phase the same with what? Of the formula. Eh? Okay. So the same as what? Z phase is equals to E phase divided by 2,222 KD KP flux divided flux multiplied by the frequency. And then this is 6,928,203 divided by 2,222 multiplied by my KD, which is 0,97. Then multiplied by the flux. What is my flux? 0,18 multiplied by the frequency of what? Of 50. Right? Then you get Z phase. You get your Z phase. And the reason why, guys, I'm taking my KP is 1. Remember on your statement they said assume the 4 pitch coils, né? So which means this coil is that pitch. That's why I'm taking my KP is what? Is 1. Né? Alright, okay. What's your answer? 357, 16. 3 decimal places. 1. Okay, so it's fine like this, né? Alright, okay. And then this one is conductors, né? So which means I have my Z phase, and then what's next? I can just calculate my Z phase because now I have this. I also have this, né? Okay. So therefore, to get my Z phase load, it's gonna be Z phase, which is 357,1 divided by number of slots per phase. Where did we get our number of slots per phase? Where's our, it's what? 60, huh?
Five
comma 953. Then you can just round off to the whole number. It's gonna be what? It's gonna be 6, right? 6 conductors base load. That's your final answer. So I know, guys, this question it gave a lot of formulas. Né? So I said the most formula that you must know, please, 1, 2 and 3. And if they ask you something and it doesn't apply, then you can look on the other formulas. For example, do you see how many formulas do we have to calculate Z phase? I have 1, I have 2, I have 3, I have 4. I have 4 formulas to calculate Z phase. So please make sure you look on this one first, and then if it doesn't apply, then you can check the other ones. Okay, any questions? Alright, okay. Let us try a different one.